the robots are indeed already here. And I'm actually an academic. I work at a university. My job is teaching students and doing research in robotics. And so really what I want to convey to you today is the trends that I see robotics research going that will ultimately turn into actual products and directions that you might be able to take advantage of in the future. So we all have this great picture of robots in our head, right? We've all watched movies. We've all read books like C-3PO, R2-D2. How many of you have seen Big Hero 6 by any chance? Okay, good number. So soft robots show up in there, as well as micro robots, which are actually my specialty. So I really liked Big Hero 6. I have kids. I was excited to let them watch it. But then we also have scary robots that we talk about, so things like the Terminator and Skynet. And if we think about the robots of reality, they kind of match what we think of in our heads. So we have robots that help us, right? They manufacture goods for us. So things like auto plants and manufacturing. We have robots that help clean our houses, like the Roomba and the Nido. And then we have scary robots, like the Reaper, that's been flown over Afghanistan and a number of countries. And so I want to be very clear here about what I mean by robot. I was actually impressed to know, when I showed up here, that robots are ubiquitous in South Africa, right? I'm not talking about traffic lights here. So what I mean by a robot is something that senses and perceives its world, makes decisions based on that, potentially with the input of a human, kind of like what we just heard about, and then acts upon that and moves within its world. So those are the kind of robots that I'm talking about. And we have two different types, and obviously a lot of hybrids in between. We have autonomous robots that do all of that on their own. So that would be like the Roomba. So you just press go, it vacuums your floor, and then goes back to its charging base. And then you have teleoperated robots, where a human is actually a big part of the control. So that's like the drone that you saw earlier when you came in here, or like the Reaper in this picture. So there's a fair amount of interest in robotics as an exponential technology. And since I'm giving this talk here, I think it's pretty obvious that a lot of people think this way. But I think one of the interesting things right now is that the robots of reality are starting to get to the point where they have similar capabilities to the robots of our imagination. Right? And this is a problem that roboticists fall into a lot, is that people imagine robots doing all of these crazy things. Well, we robotics researchers aren't quite there yet, but we're getting there, and we're getting there very quickly. So to give you an example of this rapid pace of change in robotics, this is a video that came out of the DARPA Robotics Challenge 2 years ago. The finals were 2 years ago. And so what you see here is this Atlas robot that was designed by Boston Dynamics. And this is a group down in Florida working with this. And the idea behind the challenge, and sorry the video looks a little jumpy, but the idea behind the challenge was that it stemmed from the Fukushima nuclear disaster. And the idea that if you just had a robot that could have gone in there and turned a valve, you would have saved a lot of problems. And so this robot had to complete a number of tasks, be able to crawl through or walk through a rubble field, turn a valve, open a door, get into a Jeep and drive it. So there were a number of tasks that a human would be able to do just fine, but was a challenge for the robot. And what you see in this video is a robot effectively doing household chores. And the video is sped up. The robot was a lot slower than this. But it's really not doing anything more complex than I am convinced my 4-year-old can do, although she doesn't do it. All right, so these are the kind of things that where robots are kind of at this toddler level. And interestingly, when you got to the competitions in the finals in 2015, summer 2015, what you saw more were things like this. So this is really what you see a lot in robotics of reality. So this is like my 2-year-old. Oftentimes she'll be running and crash. So this happened a lot in this competition, and there's a lot of technical reasons for that. But one of the things I want to make very clear to you is all of the robots that you see on YouTube doing really cool things, there is at least hours of footage of them doing stuff like this, right? Unless there's been painstaking tuning or it's stated otherwise. But this happens a lot in robotics, usually when your advisor is looking over your shoulder for a demo. So just last year, Boston Dynamics came out with a new version of Atlas that looks like this. And one of the things that you notice right away with this robot is it moves faster. It's much more robust to its environment. It's walking through snow here. Some of you have probably seen the Big Dog videos from the same company. This is the same basic idea. And so this was enabled through a lot of technical developments, including things like 3D printing, which doesn't seem immediately connected, but is very connected to this. And then finally, just a couple months ago, it was announced that SoftBank is buying Boston Dynamics from Alphabet. And SoftBank is responsible for the Pepper robot and the Now robot that you can probably see up there. And so these are very social. SoftBank's robots are designed to be very social. So I'm really interested to see what happens when you combine the physical capabilities of something like Atlas with the more social capabilities of something like Pepper. And I think that's ultimately the interesting direction that SoftBank wants to go. So there are a lot of reasons, I think, for this exponential growth in robotics. Obviously, you have computation, right? You throw more computation at a problem, it becomes technically easier, right? Another big thing is sensing. So one of the sensors that's been developed and has enabled the whole autonomous car thing, and a sensor is also responsible for the drones. Just having an accelerometer and a gyroscope in a small chip package is what makes drones really possible. Right? Autonomous vehicles are enabled by what we call RGBD cameras that also give you depth information in addition to the normal color stuff. So sensors have really helped push robotics forward quite a bit. They enable the robot to perceive its world much better. Right? Another big thing that is probably neglected a lot is the open source movement. So a lot of the robots, including Atlas that you just saw, actually has code that works on it that's written in what's called the robot operating system. And it's basically a database of code that you can try so-and-so's navigation algorithm or so-and-so's stability algorithm. And you can easily innovate on top of work that people have already done. And then finally, you have things like manufacturing and materials. Right? So that's really what enabled Atlas to perform as well as it did. So you had this lightweight plastics that were 3D printed, the hydraulic valves are 3D printed. You made everything much lighter weight and easier to control, ultimately. And then finally, markets. So robots have traditionally been the domain of manufacturing. We think of robots in manufacturing plants, and we think of robots for defense purposes. But now you have robots getting into the home. You effectively have Amazon Echoes on wheels that people are showing off at CES, the Consumer Electronics Show this year. So you have a lot of new markets, healthcare, all sorts of things that are really pushing innovation in robotics in different directions. So all of these things I view as adding to the capabilities of robots. First of all, making robots much more adaptable. And by that, I mean traditional robots work very well in what we call structured environments. I know exactly where everything is in my environment. But robots now are actually becoming much more capable about working in unstructured environments, right? Being able to move through a room like this seems simple to you and I, but is actually very complex for a robot. And then we have robots that are softer, safer, and much more social. And that's ultimately going to enable robots to interact with us, right? Both physically and socially. And then you have robots that are becoming more autonomous, and that's due in large part to artificial or augmented intelligence, as you just heard. So I'm going to start with adaptability. And if we look at the natural world, insects, animals, incredibly adaptive and able to get through a variety of environments. But robots typically, if I have my Roomba robot, it gets to the edge of the stage and it's like, I don't know what to do now, right? So this is Rex out of the University of Pennsylvania in Dan Kotichek's lab. And it was actually inspired by the way that cockroaches run, right? But it does a pretty good job of getting through this kind of park environment. It can run through gravel, it can run through sand, it can do a lot of pretty impressive things, including jumping around. So this is actually the basic idea is spun into a commercial enterprise called Ghost Robotics. And they do a lot. One of the things I didn't mention about Rex is a lot of that was due to the compliance of the legs. Just making the legs a little springy is what enabled it to do all of that impressive stuff. So Ghost Robotics, if you have $10,000 to spend, you can really prank your office mate by having this guy walk into the door. So it costs about $10K, but it's a pretty impressive robot. So a lot of what enables the Ghost Robotics robot is new developments in motors. And I wanted to show this in part because this was one of the reasons this motor development happened was because Songbei Kim, whose arm you see in this picture, was trying to make a robot cheetah. All right? And so he was trying to make a robot that could run incredibly fast, that could leap, as you see in the picture, and withstand the kind of perturbations and impacts that you would have in an unstructured environment. I'm very clumsy. I run into door jams all the time, right? But a robot like this could handle that kind of disturbance. And so this behaves a lot like the way muscle is, in that I can tighten my muscles and behave differently as I impact things. And so this allows us to get into new manufacturing environments, new application areas like mining, where you have a lot of bumping around and stuff as well. And then another way to become adaptable is to become very small, right? Ants are everywhere in the world. Spiders are everywhere in the world. Insects are ubiquitous, right? And this is from my own work, right? And I confess this is a real ant and a real robot, but it happens to be a particularly large ant. It's a bullet ant from South America. But the robot itself is pretty small, too, about 5 millimeters on a side. And one of the things we're doing with this is studying how to locomote when we're very small, as well as studying integration problems of how you combine motors and sensors and mechanisms at these really small size scales. And that can ultimately have a lot of impact in things like healthcare. And then you have the other idea, if I have a lot of small, simple robots, but I have a lot of them, I have 1,000 of them, this came from Radhika Nagpal's lab at Harvard, I can make them incredibly adaptable by making them into any shape I want. In this case, I have literally 1,024 robots, they're called the kilobots, creating these shapes based on different algorithms defined on each robot. So it's pretty impressive stuff that you can do if you have a lot of small, simple things in terms of adaptability. So in addition to locomotion and being able to get around your environment, adaptability is also incredibly important in things like logistics applications and manufacturing. And so this is a company where I have a friend, Right Hand Robotics, where they're actually designing a hand, a robot hand, which robot hands traditionally, unless I know exactly what my part looks like, have a lot of trouble picking up a part, especially if it's squishy or soft. Right? And in this case, what they've designed is this very compliant robot hand, much like the legs and things like Rex and the ant that you saw earlier, that's able to conform to whatever shape it's picking up, a lot like we do with our own hands. Right? But we have a lot of muscles that enable that. So we can make hands much more capable than they've done in the past. We can also do things like incorporate AI and learning networks. And so this is a room, Google, in California, and they have just a boatload of robot arms just continually trying to pick up objects and determining, was I successful? Did I pick it up, or did I not? And changing the strategy a bit each time. And based on this, I can learn good strategies that work even with very simple grippers. And this is one of my favorite new things. So this happened about in May, so a couple months ago. This came from the OpenAI project that Elon Musk has a lot of input into. And in this case, what they were trying to do is take a human in virtual reality with one episode of training on a task. And it's a very simple task, just stacking blocks. Right? But based on that one episode in virtual reality, they had a robot learn how to do the same task regardless of where the blocks were originally. Now, in stacking blocks, once again, like literally a 9-month-old can do that. right? At least 2 blocks, then they knock it down. Right? But in this case, what you're really doing is looking at this convergence of all of these different exponential technologies, virtual and augmented reality, AI, and robotics, and ultimately thinking about how I can have a surgeon in one place, right? Maybe it's South Africa, training a robot surgeon somewhere else, right? And you can really think about the possibilities that are enabled by all of these technologies coming together, which are really exciting. All right, so one of the things that adaptable robots ultimately mean for us is that robots aren't going to be left by the side of the road anymore in a lot of these applications. So we already have a lot of automation in things like agriculture and mining, but that's going to be much more so. Construction, things that require us to be adaptable to these unstructured environments are going to be allowed by robot innovation in the future. We also have things like more complex manufacturing environments, and by that I mean manufacturing environments with people in them. So the fact that I have a person working next to me ultimately will not be a problem for these more adaptable robots. So speaking of that, the question of can robots interact with people? This is the Tesla plant in Fremont, was just brought online in 2014. And what's the missing thing in this picture? People, right? There actually is one person, but she's wearing a red shirt, and so it's hard to see among the red robots, right? But these are big robots that actually have to be caged off from people, right? Instead of being at the zoo with the animals caged, right? The people are effectively caged off from the robots. And so ultimately what we want to do, if we want to augment human ability, if we want to augment human physical ability in things like manufacturing, we need robots to be able to work alongside people. And so this is Baxter, which you saw earlier. And one of the coolest things about Baxter is that this guy is actually touching Baxter, right? He's actually moving Baxter's arm, and in fact, programming Baxter what to do based on how he's moving the arm, right? A lot like you'd take your kid and you'd say, okay, you pick up your fork and then you stab it into this and you eat it, right? And you move their hand through the whole process. Like, this is how you can program a robot if you can touch it, right? So creating robots that are touchable, that can interact physically with humans is a game changer in the world of manufacturing and the world of programming, right? This is actually a fairly low-cost robot at $25,000. But I can make things even more low-cost, ultimately. This one is about $20K from Universal Robots, and this is actually in a manufacturing environment. They're making medical devices. And the idea of being able to have people and robots located right next to each other, and in fact, physically interacting, ultimately means that I can take a room much smaller than this, put a bunch of robots in there that are relatively low cost, put a bunch of people in there, and create my own manufacturing system, right? At much lower cost than has traditionally been able to. So you can actually have hardware startups now instead of just software startups. You can make things much quicker and easier with robots. And you can make them even cheaper if you change the materials that you're using and the actuation. So in this case, what you see is an entirely soft robot made out of fabric and air from Robotics. And what you see it doing right now, it's going to start trying to draw a smiley face on this picture. And you see the problem with this robot. It actually draws a smiley face about the same way my 4-year-old draws a smiley face. One of those KUKA robots in the Tesla plant could draw perfect. They could draw the Mona Lisa, right? It would do an amazing job. This one does not do so well. Right? In soft robotics, though, this thing costs about $200. It's incredibly cheap. So if I can solve the problem of making these more precise and more repeatable, I can actually use that in a very low-cost manufacturing environment. And in fact, I brought some things here. This is becoming such a thing in the robotics world of creating these soft robots that we have these floppy systems. So this is a soft robot actuator that's made from the Soft Robotics Toolkit that you can look up online. So everything is open sourced, all of the designs. Molds are 3D printed, and then I mold this elastomer, this soft rubber, basically, into it. So you can see how it's soft and floppy, And if I inflate that with air, right, so you can see it's more rigid now, and it's curling up. Right? And it can actually grab something, or you can imagine a much larger version of this. Since we are in South Africa, I can say this is very much like an elephant trunk, right? So you can think about all the crazy cool things you could do if you had an elephant trunk that cost a couple $100s, right? In terms of manufacturing, in terms of all sorts of things. So actually, if I don't kill you, I'll throw this out to you. You can pass it around. They're cheap enough that I don't care if I lose a couple. You guys can pass it. It's in the other direction there. All right, so soft robots, I think, are a really exciting direction for manufacturing, but they're also an exciting direction for other things if we can figure out this sensing problem. And in fact, my group, my lab, works on a lot of soft sensing. So I have some soft sensors right here. The idea is being able to detect kind of strains or pressures, but all with a very soft substrate that would work with these soft robots. Once I know where my arm is in space, I can make things much more repeatable in the leg. So there's a lot of interesting work in this area happening as well. And it's good for things beyond just manufacturing, right? So we can think about soft robots. The real innovation is being able to interact physically with people. And so if I think of trying to teach a kid how to walk who has some kind of neural disability, or I think of trying to teach an elderly person how to walk after they've had a stroke, a good way to do that is through a robotic exoskeleton. But Iron Man is a little too rigid, right? If I take away the iron and add rubber, it's a much more inviting thing to wear, rubber or fabric. Right, so I can think about both augmenting humans in a manufacturing context and some other kind of work context, or I can think of the healthcare benefits of this. And ultimately, there's some incredible possibilities, but once again, enabled only once robots can physically interact with people, or people can physically interact with robots. But really, the key point, I think, in addition to these robots of our imagination being able to interact with us physically, is that they can also interact with us socially. And so you have a lot of really fascinating robotics research. This is older, from Cynthia Brazil at MIT, and she's introducing Leo here to Elmo for the first time from Sesame Street. My kids would love this. So he's showing, oh, Elmo, and you can kind of see the facial expressions that Leo is making, and I want Elmo. Elmo looks awesome, right? And so being able to pick up on these social cues, as you just saw, but being able to express them yourself as a robot is another huge part of being able to interact with people. Robots also allow us to show up in places where we can't otherwise go. You may remember the US government was shut down a couple years ago, so the NASA CIO had to show up on a telerobot, right? Telepresence robot, so it's basically an iPad on wheels. I used one during my maternity leave and ended up crashing into my students. So in part because it's missing arms, right? It needs arms in order to tap on people. I think that's one of the big innovations to happen there still. So my students were very scared. So if we look at some of the innovation in this area, this was a big program announced in February in the US called the Advanced Robot Manufacturing Initiative. And Maryland is part of this, a lot of other companies and universities. CMU is the lead, Carnegie Mellon. And really what I want to emphasize through this slide is there's a lot of interest in the US in taking robots that can work with people to basically lower the cost of manufacturing in the US and enable more complex manufacturing with human capital. So effectively, once again, extending and augmenting human physical capabilities. So soft, social, safer robots ultimately mean that robots can interact with you and I. Right? We can touch them. We can socially interact with them. And there are many, many implications of that, ultimately, especially around ethics and the like, and jobs. So finally, I want to talk a little bit about autonomy in robots. So this is enabled really dramatically by the artificial intelligence that you just heard about. But obviously, there's a lot of reasons why we might want to take a human out of the application, out of the particular environment, like texting while driving and the like. So really, the way that this is enabled is through the better ability of a robot to perceive its environment. I would also add understand its environment, but that's a somewhat loaded term. At least kind of parse into categories some of the things in its environment. So this is an autonomous vehicle driving down the street. This is what the algorithm would ultimately spit out. So you have things to worry about. So the person walking across the street, along with the vectors showing you which direction that they're walking in. So red, warning, pay attention to this thing. Orange with the car driving through. It's also able to know this is a car, this is a person. And then a lot of the clutter in the background, like the trees, stop signs, that sort of thing. Although it is able to detect this is a stop sign. Although there was some recent research saying you could confuse an AI by putting stickers on a stop sign. But there's some subtleties to that particular experiment. So anyway, the idea of being able to perceive your environment is really, and through new sensors, through new algorithms, is really what has enabled this whole direction of autonomous vehicles. Whether they're vehicles that will ultimately drive you and I around, right? Maybe it's in a particular area that's well mapped and well controlled, or vehicles that could do that last mile delivery for you. So the idea, Starship Technologies is one company that's actually creating these small little pizza delivery robots or food delivery robots, but solving that last mile delivery problem that Amazon tries to tackle as well. The way Amazon tries to tackle that, in part at least, is through drones. Right? And this is often the direction people start thinking of when they think of robotics. And you just saw a drone here. We're going to get to see drone racing in the future, so creating an entirely new category of sport. But drones have incredibly useful applications, especially in areas where infrastructure, traditional infrastructure, is hard. Right? So Maryland's actually affiliated with this test site in southern Maryland, which is, there's a Chesapeake Bay is between DC and southern Maryland, and flying medical supplies across, for example. Agricultural applications, attaching a hyperspectral camera to a drone and understanding how your crops are doing at any particular time, what you need to be doing to them. Right? There's a lot of stuff there. Inspection. I get a lot of questions from energy companies about using drones for inspection tasks, and this is a whole area that's starting to come up in great detail. And then this is one of the examples that I like from the African continent. So this is a friend of mine was a technical advisor for this company called Zipline, and what you saw them do right there is package up some blood. And they put that carrier on this fixed-wing drone, so it looks like a little airplane, basically, and launch it. And the idea is being able to solve some of the infrastructure challenges, leapfrog some of those infrastructure challenges with drones, and be able to drop off your cargo at its destination. It deploys a little parachute, right? And there goes the blood, basically being dropped by the medical supply where it was needed. And this is deployed. This is actually happening right now in Rwanda. Right? They actually launched this. One of the cool things, one of the reasons it's called Zipline, is if you see the landing right here, it actually gets caught by a little line there. It's like landing onto a carrier. And they do this so they don't need the infrastructure of a runway even. Right? They can just launch this thing and capture it when it returns. They have all these fancy designs, fancy architects that they've hired to create these drone depots at various locations as well, which is very cool. So another approach to that is using Matternet. So Matternet is a company that came out of SU's Global Solutions Program, which is a summer program. They're also doing medical supply deliveries in countries like Malawi, and also in some European countries like Switzerland now, I believe. So there's some really interesting, in this case, they're taking the quad rotor type approach, which is the drone you saw earlier, right? But really interesting applications if I can take these semi-autonomous robotic systems, and these are almost entirely teleoperated in some fashion. There might be some autonomous capabilities, but take these systems and be able to use them to basically help people where they need help and at the location where they need help. And you don't need all the logistics that you would need otherwise. So autonomy goes beyond, obviously, drones and autonomous vehicles. So this is a huge area of investment in the US right now in warehousing robots and logistics robots. This is a company called Fetch. And in this case, this robot is actually using a combination of arms and being able to drive around, be able to perceive the exact object it needs to pick up, right, and place that in some bin to go off to be packed in a box. And so there's some really incredible opportunities. Amazon's pursuing this in terms of logistics and warehousing that are enabled by these autonomous systems. So autonomous systems really have a lot of implications in a lot of different areas, right? Everything from warehousing and logistics, autonomous vehicles, but also some interesting areas like medicine. So autonomous surgery, the idea of being able to have a robot do everything or a lot of the work without the surgeon's input. So I have a colleague who's working on this area. You also have some big questions that are going to come up over the next couple years, and are already here, really, about autonomy in weaponized systems. Right now, there's a guy in a lazy boy who's directing that thing around. But once you add autonomy, you've opened up an entirely new can of worms. Right? But autonomy means that you're going to be able to do a lot more with robots in these unstructured environments without the input of people. And that ultimately leads us to a lot of the ethical questions that we're going to have when we face the robots that we've created, right? Of how much autonomy we want on particular systems. It's a discussion that we need to ultimately have. Right? And there's various rules of thoughts on ethics in robotics and how you actually implement that. But it's a really interesting question that hopefully I'll get to discuss with some of you a little bit later as well. So ultimately what this means, all of these videos, all of this stuff that I showed you and told you about, is that it is a fascinating time for robotics. I feel incredibly lucky to be researching and teaching in this area. Right, we're going to have adaptable robots that are able to get through more unstructured environments, that are able to adapt to unstructured manufacturing environments. It's going to open up an entirely new way of what applications robots can participate in. We're going to have robots that are softer, safer, more social. They're going to interact with people. Right? They're going to get into, once again, new markets. They're going to enable new paradigms in manufacturing and enable some countries that haven't done a lot of manufacturing in the past to once again leapfrog places like Southeast Asia by combining robots with humans and taking the advantages of both and making more impressive products that way. And finally, autonomy is going to allow robots to do far more on their own without human input. And it is also a fascinating time to learn about robots. Right? The most often question I get asked is what robot I should buy for my kids. Right? So Lego Mindstorms is fantastic. You get to build, recreate all of these different robots. Up in the far right is the Anki Cosmo, which is really cute. I think we actually have one here as well. And then Dash and Dot. And I have all of these for my kids. They're a little young for them still, but Dash and Dot are actually great for my 4-year-old. And then one of the other things I wanted to say is that it's a fascinating time to learn about robots throughout Africa as well. So I have a couple friends who participated in this challenge presented by the African Robotics Network, or AFRON. And the idea was to design robots at the $10 price point that could allow students to explore and create new systems and explore new algorithms. And so on the right, you see both a software environment and the hardware robot, all of that done for $10, and all designed for a basic level of education to enable people to start playing with and creating new things with these robots. The one on the left is actually printed. Right? It's incredibly cheap. It's all made by this basically paper with a couple servos plopped in. So all of it incredibly low cost, enables a lot of kids to start creating and playing and learning how to learn effectively, augmenting themselves. So with that, I'd like to thank you.